Let's represent the following boolean expression in a Karnaugh map. So I'll leave it for you to verify that these terms are adjacent. So wx is adjacent to wx bar and so on. And similarly yz is adjacent to yz bar and so on. So to represent the first term in a Karnaugh map, given that we only have two literals, that's what we look for in a Karnaugh map. So we have a w and a y. So this term is represented as follows in the Karnaugh map. And you can verify this using Boolean algebra. So if we have w by x plus its complement, by y by z plus its complement, we don't alter this expression. And now we can distribute w and distribute y. And then multiplying these out, we get wxyz plus wxyz bar plus wx bar yz plus wx bar yz bar. So this here is wxyz, and this here is wxyz bar, and wx bar yz is this term, and wx bar yz bar is this term. And in a similar way, we can represent w bar x bar y in our Karnaugh map. So here we have w bar x bar in this term, and also y. So this is represented in the Karnaugh map as follows. So in a similar way, we can write w bar x bar y, and we multiply this by z plus its complement, being the missing literals, and then we distribute this, so we have w bar x bar yz plus w bar x bar yz bar. So this here is this term, where we have w bar x bar yz, and then this one represents this term. So w bar x bar yz bar. And then these next terms are straightforward to represent. So we'll look for w bar x and yz bar, which goes here. And finally, we have w bar x bar, y bar z. So this term is represented as follows in the Karnaugh map. And note that these labels in the Karnaugh map can also be represented in binary. So wx can be 1, 1, w is 1, the complement of x is 0, and the complement of w is 0, complement of x is 0, and so on. So similarly, these labels can be represented as follows.